When we're talking about equations, there's one rule we can never break with equations. And remember that there's a difference between expressions and equations. So if I have 3x minus 5, that is an expression. Okay, I can't really change the value of that. Whereas if I have an equation equal to 5, I have now an equation. There's a one rule that I have to follow with this equation. And when I have an equation, the one rule I have to follow is you have to keep it balanced. Okay, so what you do to one side, you have to do to the other side. So what are some of the properties of equations that keep it balanced? Well, I can add and subtract to both sides. Okay, I can multiply, divide on both sides. Okay, and that will keep it balanced. And we can also do like for like replacement, okay, or substitution. So if something is equal or the same, we can replace like for like, okay, which is essentially substitution. Okay, so these are some properties that we're going to work with to solve systems of equations. So a system, again, is when we have more than one variable and more than one relationship. So when we're solving these, we basically have two strategies. One is addition, subtraction, and the other one is substitution. And whatever is going to work easiest is the one we probably would choose. So it says here solve for any method. It looks like here that I can make the coefficients of x equal fairly easily. And again, if I number the equations, just to keep track of them, I can multiply equation 1 by 2, so times that by 2, and I end up with 2x times 2, which is 4x, 2x times 6, which is 12, so 2 times 6y, which is 12y, and then 2 times 22, which is 44. And again, remember our rule, we have to keep it balanced, so I don't just multiply one part of the equation, I have to multiply the whole equation, both sides, by that 2. So I'm going to add in this case. I have a zero pair of x's, so I end up with 22y is equal to 44. That allows me to solve for y. I've eliminated one of the variables. I just have y left to solve for. So y is equal to 2. So there's my solution for y. Now, system has an x and y solution. Because remember that when we look at the graph of it, they have the solutions where they intersect, and the intersection has both an x and y coordinate. So we have to solve for the other variable. In this case x, I'm just going to plug it into one of the two equations. So I'm just going to arbitrarily choose equation 1, and then I'm going to substitute that y equals 2 into this equation and solve for x. Okay, so once I've done that, again, I've eliminated one of the variables. I only have x to solve for. So when I solve for x, I end up with x equals 5. Okay, so if I were to graph these two equations, again, if we ever want to check our solutions, we can always graph. Graphing these two equations will yield the intersection of the two lines at x equals 5, y equals 2. So here it looks like, what could we do here? So I can do either substitution or match coefficients. I think in this case may be easier to match the coefficients because of these decimals, and we'd end up with decimals all over the place. So I'm going to just multiply. In this case, I'm going to multiply by 10 and find the lowest common multiple. So I'm going to multiply this by 70 and this by 20, and we'll get a common multiple and we can eliminate the x variable. So I'm going to take equation 1, and this one's a little bit more involved, so I'm just going to take equation 1 and times it by 70. So I end up with 14x minus 35y plus 70, and again, make sure that you are multiplying everything. Okay, so equation 2, I'm going to multiply equation 2 by, it looks like 20. So 20 times equation 2 yields 14x plus 60, is that 60? No, 6y minus, looks like that's going to be 94 equals 0. Okay, so then I can combine these two equations. So equation 1, which I multiplied by 70, I'm going to subtract. Again, just make sure you're careful with your negatives. Okay, so subtracting these two equations, I eliminate the x variable. I end up with 41y. Okay, 94 minus 70, negative 94 minus 70 gives me negative 164 equals 0. Solving for y. So 164 divided by 41 gives me y equals 4. Okay, so solving for x, I'm going to plug it back into one of these equations. I'll just plug it back into equation number 1. And I'm going to use a whole number of values. I could plug it back into the decimal values, but it looks like it might be easier to use a whole number values. So y was equal to 4. Okay, when I do that substitution, I have now an equation that has only x. So I'm going to solve for x. So 14x minus 140 plus 70 equals 0. So I end up with negative 70, so I'm just going to put the negative 70 onto this side as positive. Divide both sides by 14. 70 divided by 14 is equal to 5. Okay, so then we have our coordinate pair. Our solution to our system is x equals 5, y equals 4.